So this is geometry lesson 1.1, points and lines as locations. So the big idea or the learning target here is that objects and locations in the real world are often represented by points and lines geometrically so that they can be studied. So first thing we're going to do is we're going to run through a couple definitions and then a couple practice problems before you jump into your work for today. So let's start with the word coordinate. Going through pre-algebra and algebra, you've used the word coordinate before. You're probably used to seeing it in a 4-quadrant graph where you have an x and a y, but a coordinate can just be on a number line and just be a single digit number. And so it is a number that matches a point on a line. And forgive my handwriting, it is terrible. Now, sometimes that is just a number line, and sometimes that can be a 4-quadrant graph. That'll vary as we go through things, but a coordinate is just a number or a set of numbers that matches a single point on a line. Okay, when you want to find the distance between 2 points on a number line, there's a formula for that. So if you've got 2 points on the number line, we're going to call one of those points A and one of those points B. If you want to find the distance between them and you have the coordinates or the values of each one of those letters, it is going to be the absolute value, which are those bars on the outside, of A minus B, or you can do it the other way around as well, the absolute value of B minus A. So either way, we'll get you the correct answer. Quick review, those bars are absolute value. Which in review is the distance from 0, and basically it just creates a positive if you get a negative. So the absolute value of any positive number is just the number, and the absolute value of a negative number is going to be the opposite. It's going to be the positive value. So if you think about any numbers here that we're subtracting, let's just say this was 10 minus 2, you're going to get 8, and then you have to take the absolute value. The absolute value of 8 is just 8. If we had it over here, b minus a, 2 minus 10, you're going to get negative 8. But then when you take the absolute value of negative 8, you get positive 8. So both of these would result in a positive 8 as the distance. Okay, and that's why it doesn't matter which way we subtract the two numbers. As long as we're taking the absolute value, we're going to end up with the same distance. So distance notation, if we're just talking about the letters that represent the endpoints here, if we want to find the distance between R and S, it's simply written as RS. You just put the letters together, they're connected. Okay, that's your distance from R to S. So if you had an actual distance, you could say RS equals 8, and that would mean the distance between R and S is 8. Okay, and then eventually we'll talk about a line, and you can actually put the line there. But this doesn't necessarily mean that there's a line connecting R and S. This is just the distance between them. All right, in an exact location, if we're talking about a specific location, that would be known as a point. And a point does not have a size or a shape or an area. So it's just a location, no size or shape. All right, now synthetic geometry is just talking about a specific type of geometry. But under that folder, we're going to talk about points and lines. That's what we're looking at today. And we kind of already went over what a point is. That's an exact location. And similar to what I was just kind of hinting at here, a line is the shortest path between any 2 points. So you have 2 points. If you connect them directly without going around and no curves, just from one point to the other, that is a line. All right, so number 1, let's jump into some examples now using all that information. We want to find AB on the number line below. So first of all, AB is already in distance notation. All right, so when you see AB, that just means the distance from A to B. So we want to find out how far apart are these two on the number line. So it doesn't matter if you go from B to A, we talked about that, or from A to B, it's going to be the same. So both of these points, instead of going all the way from one to the other, both of them have their own distance away from 0. So -2, how far is it to get to 0? 3, how far is it to get to 0? Well, from -2 to 0 is 2, and from 0 to 3 is obviously 3. And so all together, this distance here is 2 and 3 together. That's 5. So we would say AB equals 5. All right, now let's use the formula. We're going to find the distance between -5 and 16. So again, using our formula up here, let me see if I can get this in some better focus here for you. There we go. Much better. All right, so if I'm going to find the distance between these using this formula, I can do either the absolute value of A minus B, or I can do the absolute value of B minus A, and they're both going to give me the same answer. And so I'll do both of these for you and show that it works. In your work, you would only need to do one. If this was a homework question, you don't need to show it both ways. But I want to show it to you both ways so that you see that either one will give you the correct answer. So if I do A minus B, I would assume this is A and this is B just based on the order. So -5 minus 16. And over here, it would be the opposite. It would be 16 minus -5. Now you can run that through your calculator. This is going to be -21. And this goes plus plus. This is going to be positive 21. And when you take the absolute value of -21, it's 21. Take the absolute value of positive 21, it's also 21. So either way, we get the same answer. Both of these would be fine. Let's do the same thing here, two negative numbers. What's the distance between -56 and -15? If you imagine them on a number line, -56 way to the left, -15 just a little bit. How far apart are they? We can just run this formula. So -56 minus -15. Or we can do -15 minus -56. Run that through your calculator, and you're going to get -41 here, because this goes plus plus. So -56 plus 15, go up 15 on the number line, you're at -41. Here, go plus plus, so it's -15 plus 56. We're going to go past 0 into the positives. You're going to be at positive 41. Absolute value makes both of them positive if they're not already. And they give you the same answer. So again, on your homework, you don't have to show it both ways. But I did want to demonstrate to you that either way will get you the same answer. All right, last one. Number 3, we're going to draw a number line. So the numbers -10 through +10 are shown. So let's draw a number line. I'm going to put 0 in the middle. Since we're going from -10 to 10, 0 would be directly in the middle of those two numbers. And we're going to count both ways. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's -10 because I went to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's +10 to the right. Okay, so I have drawn the number line. So let's answer the question now. A circle is drawn with a center of 3.5. So here's 1, 2, 3. 3.5 would be between 3 and 4. So right here, that is 3.5. All right, that is the center of the circle. One of the points, so the circle is going to go around this. One of the points that intersects the number line has a coordinate of 8. So here's 10, here's 9, here's 8. And so we've got this circle that goes around 3.5. It's going to hit out here at 8. So obviously it's going to go down here. It's going to end up over here somewhere. Now what we know about a circle is from the center to the outside, if it is a circle, it's equal. It has the same radius is the term we would want to use there. And so they're going to ask us, what's the other point of intersection? So where over here is the circle also going to hit the number line? So what we need to do is we need to figure out, well, how big is the radius? If we're hitting out here at 8 and the center is 3.5, that distance from 3.5 to 8 is going to be the same distance on the other side. So going from 8 to 3.5, we can count. It's 1, 2, 3, 4, and a half. Okay, and then going the other direction, we would go a half and then 1, 2, 3, 4. So we've gone the same distance both ways. The radius of this circle is 4.5. Again, from 8, 7, 6, 5, 4, and then down to 3.5. And we go a half. Okay, we're at 3. And then we go down 1, 2, 3, 4 for a total of 4.5. And that drops us to right here. And that would be -1. Now the distance from -1 to +8 is 9, right? And if I added 4.5 and 4.5, that gets me 9. So the entire distance across here, going back to some vocabulary words we should know, that's the diameter of the circle. So if I have this big circle, and it's not perfect, but you get the idea. The radius is 4.5. The entire diameter would be 4.5 plus 4.5, which is 9. And then to answer the question, what is the other point of intersection? That would be -1.